So here we're looking at the chiller again, and despite me having put in exactly the right amount of gas, I mean, I weighed it out with the scale and everything to the gram. It worked. The system was working very nicely. But then, after a couple hours, the compressor would start. The number 2 compressor would start overheating again. So I went back and checked the ohms. Right now I'm checking the amperage, but then I also checked the ohms while the compressor was off, and the compressor windings, they all checked out to be apparently fine. But then why was it overheating? The other one next door with all the same conditions, it's not overheating, and this one was overheating. Temperature was going up and up and up, but only after a couple hours. So it was very weird because it was pulling less amps. You would see it pulling 11 amps, and the other one was pulling, maybe 12 or more. Yet the compressor was doing less work, was getting hotter, and the compressor was doing more work, was staying cool, which doesn't make sense, right? Usually an electric motor that works more gets hotter. I checked everything else, so finally this is the expansion valve, and what I thought it must be the expansion valve. So to check this, I took the sensing valve off. This is the sensing valve here, which senses it has a little amount of the same refrigerant, same 407C inside it, and this drives the diaphragm and the expansion valve. So what I did then, once I waited for the system to start doing the fault and overheating, and take the sensing valve off and hold it against the condensate before the superheated condensate, and then also handle against here where the expansion is, where it's very cold. So then by taking the valve off where it's supposed to be mounted and holding it onto alternating the hot side and the cold side, you should see like a distinct change in the pressure gauges, which I did not see. So what was happening, I now put a new expansion valve in. What was happening, this is the old expansion valve here. So what was happening, this is like a very precise instrument inside, and it's got a piston that slides up and down. This is the diaphragm that drives the piston. You can adjust the superheat. This is the liquid line here. This is the flash gas after the expansion. This comes from the low pressure side. So this is another reading the valve gets. The valve can get its information basically from the low side pressure that comes in here, and from the bulb temperature that is here, and obviously it also knows the pressure of the incoming condensate, and then it has a spring inside it. It has a diaphragm. This is a very thin pipe, and in here is some of that same 407C refrigerant. So what was happening, obviously when it's cold, this body will shrink a little bit, and apparently what was happening, only once the system was very cold, once this part of the system was very cold, like this you can see here, it's all iced over, only then did the piston start jamming, and then what was happening, the compressor was not being supplied with enough refrigerant, despite there being enough and maybe even a little too much refrigerant in the system. The compressor was being starved of refrigerant, and although since it gets less refrigerant, it has less refrigerant to compress, and then actually does less work, and therefore you see the amperage drop. Yet it's still overheating because it's still doing a certain amount of work, and it's not getting that flow of refrigerant. So once I knew that the expansion valve had this very, very strange problem that would only happen once the system's been running a few hours. This is why every time I'd run a diagnose, it would check out fine, but then still overheat. Yet still not be the compressor. So very, very tricky, especially since it's like a 2-compressor reversible setup. Anyway, I put the other expansion valve in. Obviously I couldn't find this is quite an old chiller, so I couldn't find the same one, but I got it with the same values. This is a Danfoss, and then the one I put in is a Sporlan. Of course, it also has to be kind of small. It's a very tight space. I mean, to solder it in there and install it behind all the stuff is not that easy. So this is a pipe cutter. So I mean, when you change anything on the system, obviously, like, you don't want to get any debris inside of the coolant lines, because they will just go and break the expansion valve again. But this might have happened with the factory when they built this. Maybe there was some little bit of dirt in there that then scuffed the piston, and that's what happens. So the good idea is like this cutting tool will actually cut the pipe, the copper pipe, without doing any shavings or without doing any debris. It will not cause any shavings, and it will not make any dust or anything like that. But then once you cut it and you then clean the pipe with sanding paper or whatever you use, there's a risk of getting debris in. So it's a much better idea to first get the line really clean before you cut it. Say I want to cut it in here, I will get it really clean and only then cut. So then once you've done the cut, you're not going to create any more shavings in there. And then the other thing, when you solder in the valve, you have to get it very hot, because this is like a high pressure system and there's a lot of you cannot use soft solder. You have to use a hard solder, and this hard solder needs, like, the flame is 3000 degrees or something. It's very hot. So that can also damage the valve. The valve has a diaphragm and there's different stuff inside. So what this blue stuff you see here, this is a heat sink paste. So what this does is wick away the heat of the body of the valve while you're doing the soldering down here and up here. That will wick away the heat and also give you an indication if it's getting too hot. It will change color. So you can see on here you still got the paper QR code sticker. You can tell, although this was very, very hot, obviously, like melting copper and silver, whatever. Here, not even the paper sticker got brown, so it stayed totally cool. So this will ensure that when you install the valve, you will not damage it while you're doing it. Again, maybe this is what happened in the factory. Maybe it got too hot. Who knows? If you don't have the heat sink paste, you could use a wet sock, like wrap it in a wet sock and then wrap it in aluminum foil. So the aluminum foil will take away, like, the radiant heat from the flame, and then the wet sock will hopefully, you know, keep the temperature below 100 degrees or whatever. But in this case I had the right paste, so that's much better. Next thing, okay, this valve, actually this is a kind of an industrial valve. You can actually, it has a superheat adjusting skew. You can open it here and you can change the superheat if you want more or less superheat. And here this is a little tricky to measure because the heat exchanger, I mean the evaporator, is in this case, but you can still feel the temperatures. You know, in a normal heat exchanger, let's say like a heat exchanger you'd have like on an engine or something, the heat exchangers, you'll have a gradual increase of temperature throughout the heat exchanger. Let's say you have the cold gas coming in here, well, it will get progressively warmer as you go up. If you measure the temperatures, you'll find it gets progressively, but here you can see it doesn't change much. The reason being, what increases in the evaporator is actually during the first 3/4 of the evaporator, you're increasing the enthalpy of the flash gas, which is like a gas liquid condensate mix. So what's happening, the gas is absorbing energy, it's absorbing latent heat, so it's not increasing in temperature, it's increasing in energy. What is increasing in the gas is the enthalpy, it's not the temperature. So you will find a similar temperature from the very cold down here. It will maintain that temperature about 2 3/4 up the heat exchanger. Only once all the enthalpy has been absorbed, it's only then will you start seeing an increase in temperature. So first 3/4 you're increasing enthalpy, the next quarter you'll be increasing temperature. Yeah, if the system is charged in the right way. And yeah, so you can make these adjustments in the back here if you would have to. I haven't adjusted this. I use the factory setting. It's for R407C. I'm hoping that will work all right. You can see the compressor is actually running really nice and cool. It's running in what? Look at the side, it's 50 degrees. Up here it's a little hotter, 70, but that's good. The one before I changed this valve, it was running at 150 or more, and would then actually trip out and have like a thermal protection kick in. This is the sensing valve. You see right now it's quite cold up here. The sensing valve should be mounted, you know, maybe on the side of the hose. Have some insulating. I still have to secure this insulating so it's actually reading the temperature in the pipe and not getting any influence from around. But anyway, the system's been running now for like 12 hours, and the temperatures are very stable, they don't change, so it seems to be working fine. And yeah, it was a very strange one because everything looked like the compressor, like any diagnose would tell you, okay, it's a burnout compressor because compressor's doing less work, yes, it's getting twice as hot. You know, that doesn't make sense. If an electric motor is getting twice as hot while doing less work than another identical one, the first conclusion would be, well, that electric motor is burned out or has something wrong with it. But in this case, it was just being starved of refrigerant. And the same thing, measuring the superheat and the subcool of the system is very hard because, let's say, you know, the expansion valve, its job is to keep the superheat constant. So if you have too much charge or too little charge, you probably won't see it so much in the temperatures because the valve will do its best to compensate for that. Anyway, now it's running fine. And what I'll probably do, I'll have to do some kind of, this electronic control system is not great either, so I might have to make a little controller myself that works better.